Hello friends, I am Engineer Nasir. In this video we will learn a quick, easy and simple method for calculation of external static pressure for HVAC ducting. To calculate the external static pressure for duct, we use this formula: total duct equivalent length into friction loss rate, or ESP equal to straight duct length plus duct fittings equivalent length into friction loss rate. For straight duct we measure the total length, then for fittings we select the equivalent length. To estimate the external static pressure of this duct we will use two methods. Number 1, we will select the maximum pressure drop rate for this duct segment and we will multiply the total equivalent length of this duct with it. Number 2, we will select the actual pressure drop in each segment and we will multiply the equivalent length of all duct segment with corresponding pressure drop rate. In this duct we have two dimensions. One is 600 by 350 millimeter, or in inches 24 by 14 inch. The second dimension is 450 by 250, or inches 18 by 10 inch. To calculate the pressure drop, we will use McQuay calculator. For 24 by 14 inch, 2000 CFM is 2000, then 24 by 14, so we have the head loss equal to 0.061 water gauge per 100 feet. Then for 18 by 10 inch, 1000 CFM, it is 1000, then 18 by 10. For this you can see here the head loss is 0.08 water gauge per 100 feet. We can find pressure drop for the duct using duct friction loss chart from SMACNA, and we will do this exercise at the end of this video. Straight duct length is 32 feet. Now we will calculate the equivalent length for duct fittings. Now we will calculate the A1 by A2 ratio for this reducer. The larger dimension is 32 by 14 inch and smaller dimension is 24 by 14 inch. Then A1 by A2 is equal to 1.33. We have calculated the A1 by A2 ratio for the reducer, which is 1.33, and the reducer is converging type, so we will use this table. As per SMACNA, for converging reducer the maximum allowable angle is 60 degrees, so we will select for maximum degree this column, and for 1.33 A1 by A2 value we will select this row. So let us select this row from here and column for 60 degree from here. So at the intersection of this column and row we found the equivalent length for this reducer, which is 7 feet. Similarly, A1 by A2 ratio for another reducer whose size is 24 by 14 and 18 by 10 is equal to 1.87. For this reducer we have A1 by A2 value 1.87, so we will select the row, this row which we have 2, and this reducer also converging, so we will select the maximum angle 60 degree. So in this way the equivalent length for this reducer also is 7 feet. Now we will calculate the equivalent length for this 90 degree elbow. Elbows are of two types, one with vanes and another without vanes. Let us consider our elbow is without vanes, so we will use this table, and the radius is equal to 1.5 times width, so R by W value is 1.5. Let us select from here, we have 0.5, 1 and 2. You can see for 1 we have the equivalent length 31 feet and for 2 23. So for safety we will consider 1. So let us select this row for 1. Then from here we will select the value H by W, height by width. Height we have 14 and width 24, so H by W is 0.58. So we have value here 0.25, 1 and 4. So we will select the value 1 from here. So in this way we have selected the equivalent length for this elbow equal to 24 feet. Now we have calculated the equivalent length of the duct. Straight duct 32 feet, first reducer 7 feet equivalent length, then elbow equivalent length 24 feet, then another reducer equivalent length 7 feet. We already selected the head loss. For duct size 24 by 14 inch, it was 0.061 water gauge per 100 feet, and for duct size 18 by 10 inch, it was 0.08 water gauge per 100 feet. So we will select the bigger value from here, which is 0.08 water gauge per 100 feet. After applying this value in the formula, when we make calculation, we get the total external static pressure for this duct equal to 0.06 water gauge. Second method is to add the equivalent length for all duct segment having same head loss value. This duct segment has the head loss value 0.61 and this duct segment has the head loss value 0.08 water gauge per 100 feet. Then after calculation we get the total external static pressure value 0.045 water gauge. If you have elbow with vane, then you can use this table to select the equivalent length, but for elbow without vane you can use this table to select the equivalent length. For Y you can consider the double elbow equivalent. For return air branches you can use this table. For rectangular branch like this you can use this table. For rectangular branch with 45-degree entry, you can see this 45-degree entry, you can use this table, and for round branch like this you can use this table. For supply air system, for rectangular branch like this you can use this table. For rectangular branch with 45-degree entry you can use this table. For round branch you can use this table. For return air system, for round conical you can use this table. For rectangular reducer you can use this table. For supply air system for reducer, for expanding flow rectangular straight side, you can see this is straight side, you need to use this table. It is for return system. But for supply air system, for rectangular reducer, then you can use this table. These tables are created based on the velocity in the duct 1300 fpm and friction loss rate of 0.1 water gauge per 100 feet of duct. If you have different velocity, so for more accurate result, if your friction rate is 0.1, then you can multiply this equivalent length by this factor. If the friction loss is your duct is 0.08, then you can multiply the equivalent length by this factor. We can also find the pressure drop using Smegma table and charts. First we need to select the round diameter for the corresponding rectangular dimensions. We have two rectangular dimensions, 24 inch by 14 inch, and the second is 18 inch by 10 inch. In this column and this row are for rectangular duct dimensions, and in between are the diameter of the circular equivalent. So we have one dimension 24 inch. Let us see from here. We will select this row for 24 inch. Then the second dimension is 14. We will select from here 14. So for the duct size 24 by 14 inch, the round diameter is 19.9 inch. For the second one we have 18 by 10 inch, so we will select from here the 18. And the second one 10. Let us select from here 10. So the circular equivalent for 18 by 10 inch is 14.5 inch. Now we will select the pressure drop inside the duct using the friction loss chart from SMACTA. For 2000 CFM we have the round duct diameter 19.9. You can see these lines are for round duct diameter. Here we can see 18, 20. So let us draw a line parallel to it for 19.9. Then here these values are for CFM. Our CFM value is 2000. So we will draw a line for 2000 CFM. And here you can see it is the friction loss or pressure drop inside the duct in water gauge per 100 feet. So at the point of intersection of these two lines, we will draw a parallel line along this line that will give us the pressure drop inside the duct, that is 0.06 water gauge per 100 feet. Now we will select the pressure drop for 1000 CFM. For 1000 CFM we have the round duct diameter 14.5 inch. So let us draw a line for 14.5 inch round duct diameter. This is 14 and 16, so 14.5 it will be here somewhere. Then we have 1000 CFM. So from here for 1000 CFM we will draw a vertical line, and at the point of intersection of these two lines we will draw a horizontal line that will give us the pressure drop in the duct in water gauge per 100 feet, and from here you can see this value is 0.08 water gauge per 100 feet. Now we found the value for 2000 CFM. Pressure drop is 0.06 water gauge per 100 feet, and for 1000 CFM 0.08 water gauge per 100 feet. These values are same which we have calculated using McQuay calculator.